Before we start the show, don't forget to check our new ebook, Kill All Bugs, Learn Software Testing in One Day. For a limited time, it's only $9.99. Links in description.
Welcome back to the Deep Dive. This is where we take a complicated programming concept, look at the essential source material, and basically give you the fast track to being well-informed. Today, we're getting into something fundamental, the structural core of, well, almost any code ever written, the variable.
Right, but we're not just here to define what an integer is.
No, not at all. Our mission for this deep dive is to really unpack the critical differences between local and global variables. We're talking trade-offs, best use cases, all the stuff that defines clean, stable code.
And to even start that conversation, we have to land on the single most crucial concept here, which is scope.
Scope.
Yeah, and scope isn't really about the variable itself. It's more about its visibility and its lifespan.
So, like, who is allowed to see this variable, and for how long does it even exist?
That's a perfect way to put it. Think of a function that's running. Its scope is like a tiny self-contained meeting. Any variable you declare inside that meeting, it's private. Only the attendees can see it.
Right. And that distinction, that private versus public, it's literally just about where you type the declaration.
Exactly.
And broadly, you've really only got two main places. You can declare them inside a function, maybe a specific block of code, and those are our local variables. Or you declare them completely outside of all functions, way up at the top level, and that's what makes it a global variable. So let's start with those fundamental mechanics, the residency status, if you will, because that location dictates everything.
It really does. And the difference in that residency is stark. A local variable is like a temporary visitor.
Okay.
It's created the moment its function starts, and it is immediately and permanently lost. It's destroyed the nanosecond that function terminates.
So it's ephemeral, a blink.
A total memory blink. The global variable, on the other hand, is a permanent resident. It's created really early as the program itself starts up.
Even before the main part of the code runs.
Yeah, before the main flow kicks off. And it sticks around for the whole ride. It's only lost when the entire program shuts down.
And the computer itself must treat these two types differently, right down to the memory allocation. You said local variables are destroyed so quickly. Where are they actually stored?
So local variables are usually stored on what's called the stack. And the stack is just this fast, dynamic piece of memory that's used for managing function calls.
And because it's managed automatically.
Exactly. When the function exits, that memory space is just, poof, reclaimed. It allows for that super quick creation and destruction.
Whereas globals,
yeah,
they can't be on the stack then.
No, they can't. Global variables are put in a fixed location. The compiler decides where at the very start. And that stability is required precisely because everything in the program needs to know where to find them at any time.
That fixed location, that brings up a really important detail our sources flagged about initialization. What happens if I, the programmer, just forget to give my variable a starting value?
And what's so fascinating is that the consequence is totally different depending on the scope. Yeah. If you forget to initialize a local variable, that spot on the stack, it's just going to contain whatever random data was left there before. We call that a garbage value.
So it's just unpredictable noise.
Complete noise.
Ooh.
But if you fail to initialize a global variable because it lives in that fixed dedicated memory, the system automatically initializes it to 0. That's the default.
Wow, garbage versus a guaranteed 0. That tiny technical distinction seems like it could be huge when you're trying to debug something.
Oh, it's massive. You could spend hours chasing a bug from some random junk data in a local variable. The global at least gives you that consistent, predictable baseline of 0 to start with.
Okay, so we know where they live, we know how they start, but the real question is, what can they see? This gets to the core trade-off, right? Visibility versus data sharing.
This is it. This is the strategic choice every programmer makes.
So let's start with safety first, the local variables.
They are locked down completely. Data sharing between functions is fundamentally not possible. A local variable can only be accessed by code inside the function where it was declared.
That's why you have to pass parameters.
That's exactly why. If function A needs a value from function B has to explicitly hand it over, and the benefit there is huge. If function A then changes that value.
Function B's original variable is totally safe, untouched.
Right. That isolation equals stability.
Okay, but now the flip side. Global variables are so convenient. Why do so many experienced programmers treat them like, I don't know, a necessary evil? What's the hidden cost?
Ah, convenience. It's the siren song of programming, isn't it?
It is.
With global variables, the picture flips entirely. Data sharing is possible. Multiple functions can access that exact same global variable.
Which means no more tedious parameter passing.
None, it's just
Forgettable.
everywhere.
So if function A modifies that global variable, the change is immediately seen by function B, function C, the whole application. That sounds great for moving data around, but the risk of unpredictable results, that must be enormous.
It is the single biggest risk. Since any statement, anywhere in the program, can change that one single source of truth, tracking down an unwanted change becomes a nightmare.
You lose control. You have no idea who changed what or when.
You've got it.
Okay, this brings us to the strategic assessment, the why should you care part. Let's drill down into the real advantages and disadvantages of each one. Let's stick with local variables first. Beyond just isolation, what are their killer features?
Well, the primary advantage is stability, especially in multitasking. Our sources really highlight this. Local variables basically solve concurrency issues.
How so?
Imagine you have 5 different tasks running at the same time, and they all need a variable called, say, temp counter. If you declare it locally, each of those 5 tasks gets its own separate instance.
So they aren't fighting over the same piece of memory.
Exactly. They aren't tripping over each other trying to modify the same variable. It guarantees your results are predictable. The tasks stay isolated.
Plus, you've got that memory benefit we talked about. They're great tenants. They only use space when they absolutely have to, and then they're gone.
And don't forget just the pure coding convenience of name reuse. You can have a variable named it in 10 different loops in 10 different functions.
And they never conflict.
Never. Because their scope keeps them separate, it just makes code cleaner.
But the downside is clear. If you have data that lots of functions need, all that repeated parameter passing can get pretty messy.
It can start to look very repetitive, yes.
Okay, so now let's talk about the temptation of global variables, that accessibility.
It's a powerful temptation. Their main benefit is that universal access. And for certain things, it's ideal. Think about application-wide constants.
Like a configuration setting.
Perfect example. Something that genuinely needs to be the same, unchanging piece of data everywhere. You declare it once, globally, and you're done. It simplifies everything.
And I can see it being useful if a few functions are working together on the exact same piece of data.
Absolutely. It saves you the overhead of passing it back and forth constantly.
But let's talk about those disadvantages, because they sound significant. The immediate cost of keeping them alive for the whole program. What is it?
The immediate cost is memory. They can become a serious memory hog. If you declare too many global variables, or very large ones, they sit in memory until the program terminates.
Which could lead to out-of-memory errors.
Potentially, yes. Especially in a long-running program.
And what about that maintenance nightmare you mentioned? What happens when a programmer needs to refactor something?
That's where the pain really sets in, because that global variable is visible everywhere if you need to rename it or get rid of it.
You have to hunt it down in every single file.
Every calling module. You have to change it everywhere. It turns a simple update into this huge, risky maintenance task.
So let's zoom out. We have this clear tension. Local variables give you stability, memory efficiency, predictability. Globals give you convenience and broad access, but with these huge risks of memory bloat and unpredictable side effects.
And if we look at the big picture, the sources all agree. Both are necessary tools. You need them both. But the universal advice from the industry is crystal clear.
Which is?
It is always, and I'm quoting here, advisable to avoid declaring unwanted global variables. You have to be incredibly intentional.
So the takeaway is, use local by default. Only reach for global when the design absolutely positively demands it.
Precisely. And let's leave you with one final thought to mull over. Something that connects all these mechanics.
Okay.
Programmers sometimes use a technique called shadowing. This is where a function intentionally declares a local variable with the exact same name as a global one.
To hide the global one, forcing the function to use the safer local version.
Exactly. But think about the cascading effect on debugging. If that programmer forgets to initialize their new local variable, what value does it have?
Garbage value, whatever was on the stack.
Right. But if the code had been relying on the global version before, what was its default value? 0. So what happens to the stability of your application when you suddenly shift from a predictable, reliable default of 0 to an unpredictable, random garbage value? All because of that shadow.
That's a fantastic challenge. It ties together initialization, scope, and risk management perfectly. Thank you for helping us dive deep into this. We will catch you next time.
Hey, yo, haven't you checked out our new book yet? Link in description.